Hi everyone, so today we're gonna cover concurrency in Java, and we're gonna see what is the racing conditions and how to solve them with the mutex. So concurrency is a mechanism of running parallel code of blocks simultaneously, and modern operating systems allows to execute code in different threads. So in Java we have an access to those operating system threads, and what's crucial to know about the threads is that when they switch, they actually preserve and save the state of internal registers or state of the local variables saved to CPU registers in specific parts of memory, and then they load this memory when they switch those threads. This mechanism is called the context switch. So this switch actually leads to specific issues, which is called as the racing conditions. It happens when the thread is interrupted during the read-write calls, and when it's going to be switched back from the other thread, it actually produces the errors related to the state of the resource shared between those threads. So in order to solve this kind of challenges, the number of mechanisms are introduced. The one of them is called mutex. Mutex stands as a mutual exclusion, so this is a sort of a lock for a resource or represented as an object in Java. It's also called as a monitor in some literature. So the monitor is actually an object and some log that allows to solve those racing conditions state. So okay, enough been said, let's go switch to the code and see how it works on a practical example. So we're gonna implement two simple classes. The one is like counter and the other is counter service. So the counter will be pretty simple. It will have an internal field like an int, and it will also allow to increment this internal field as counter, and it will also offer some method that allows to read the current value of the counter. So pretty simple. So two public methods and internal field of a counter. We're going to implement the counter service. It will have also the main method that start the application. The counter service will have a reference to the counter object. And yeah, so this is how we made them. So we made the counter object here, and then we're able to create a new counter service and to pass a reference to the counter we just created. So in order to implement concurrency and threads in Java, we have two options. The one is to implement runnable interface, and the other is to extend superclass threads and implement one of its method called run. So threads gives us the possibility to put all of the concurrent code in a run method, And it also gives us a method called start, and the start method actually runs the thread in a new thread comparing to the current thread of execution. So also one of the helpful methods of the thread is sleep. It allows to stop the execution of the current thread and to switch the execution to the other thread. Also, as we referenced before, the context switch actually occurs when we switch between the different threads. The sleep method also throws an interrupted exception, so we need to process this. So we need to put those in a try catch block. Interrupted exception. Yeah, that's correct. So here we can start the thread, and what we're gonna do is just simply increment the counter and get counter, and just to print out the current state of the counter. So we can start a number of threads here. Let's do about 5 of them. Yeah. As you can see, it produces results. Let's try once again. So as you can see, it produces the results that's actually not to be what we have expected. So it was executed 5 threads, and because we have started them with a sleep, they started to be switched between the counter increment and the counter get counter, which actually resulted to those race conditions to our counter object. So there are a number of ways to solve that. The one is to introduce the mutex. So the mutex actually in Java are not introduced and aren't used explicitly. They are used implicitly by using the synchronized block of code. The synchronized block of code tells Java virtual machines that we would like to block the execution inside of this synchronous block for a specific object with it. In our case, this is the reference to counter object. So all of the methods inside the counter cannot be called with interrupted thread, so the other thread has to wait until the current thread executes all of the methods on the current object that has been put into synchronized block of code. So if we're gonna run this, it's gonna give us the result as we expected. So 1, 2, 3, 4, 5. Yes, looks to be solving our issue, but what's also interesting to notice is that we cannot just put a synchronized block of code on some variable, so it always needs to be an object. So basic data types wouldn't work. So we're gonna have this way. It's not going to work. So you always need to give an object the counter. So what it does, it introduces the mutex internally to the counter object that locks the object from being executed multi-parallel threads. Another possibility is to use an actual direct execution of a lock. So the direct lock is called reentrant lock. So let's try to do this. Reentrant lock. So the reentrant lock is a kind of an explicit lock. You need to put it as a static, so it appears to the class, and let's call it lock. So doesn't accept any parameters, and here you can just use this lock. And instead of this block, we just release the lock. Just we have finished working with it. So it produces the same results as an explicit synchronous block of sport. So as you can see, 1, 2, 3, 4, 5 works very well. Also, what's crucial is that we would need like one lock for an object. So if we're gonna only be static here and made them like available for every counter service, it wouldn't give us any results. Okay, so it would be hectic as before. That's obvious. So yeah, two types of locks are available for mutexes. In Java, this is an explicit lock with a reentrant lock, or an explicit lock with synchronized block of code. Reentrant lock also gives us an additional functionality, so it allows us to see a number of threads that are actually put in a queue to access the resource. So get qlent allows us to see this number. So let's try to run it this way, so you can see the number of lock. So as you can see, there's like 4 threads and 3, 2, 1, 0. So yeah, that's it. Thank you for listening, and if you like the content, please consider subscribe or supporting the channel by joining or some making donations. So hopefully this was helpful.